Okay, so we've learned how to take the GCF, which we'll still talk about from here on out. Then we learned how to take the difference of two squares. Now, when it comes to factoring a trinomial, that is a three-term problem, okay? We are going to learn some new rules. So I could break it down. When I'm looking at these rules, okay, I know it looks so overwhelming, but this is a good little table to help us figure out how to set up each problem, okay? When I'm looking at these, we are looking at what sign C has, okay? And then, so we're going to look at what sign C has. So if C is positive, okay, then that means my signs are going to be the same. And then how I know what my sign is going to be is depending on what the B is. So if C is positive, that means they're going to be both positive or both negative, depending on what B is. If C is negative, okay, then that means they're going to be different. And that means one's going to be positive, one's going to be negative. And how I know which one's which is, again, depending on the B, okay? So I really just going to jump right into it, and then you can decipher this a little later. But let's break it down. So I have my trinomial here, okay? So I know it's going to break up into two binomials. So my C is positive. That means that my two signs are going to be the same. And how I know what they're both going to be is because of the B, the middle term. And since B is positive, that means these are both going to be positive. So that's how I can determine my signs. Now, I don't want to put those there because then it makes it look like a plus minus. Okay, now here's how I teach it, is I read it backwards. So what I do is I'm looking for two numbers that multiply to get 12, but add to get positive 7. See how I read that backwards? Multiplies to get 12, but adds to get positive 7. So numbers that multiply to get 12, but add to get 7 would be 4 and 3. And there's my answer. X plus 4 and x plus 3 are my binomials. Now, I can check my answer by working backwards. So I'm going to do the FOIL method. X times x is x squared. Outer, x times 3 is positive 3x, and positive 4 times x is positive 4x, and then last, 4 times 3 is positive 12. So if I look at my middle two terms, I can combine those. They combine to be 7x, and then plus 12, which was what I began with. So there you go. So I'm going to continue this method. So 2, I have n squared plus 9n plus 20. Again, I'm going to break it into two binomials. And it's always going to be n times n, or whatever the variable is. Then I look at my C. C is positive, so I know that my signs are going to be the same. And the B tells me that my signs are both going to be pluses. Okay, now I read it backwards. What can I multiply to get 20, but add to get positive 9? Think about it. Multiplies to get 20, but adds to get positive 9. And I come up with 5 and 4. 5 times 4 is 20, and they add to get positive 9. Again, if I were to FOIL this, I could check my answer to see if I get back to my original problem. Okay, number 3. So I'm going to break it up into two binomials, h times h, because that's my variable. Then I look at my C. C is positive, so I know they're both going to be plus, plus, or minus, minus. Since B is positive, that means they're both going to be plus. Then I read it backwards. What multiplies to get 18 but adds to get 9? Two numbers that multiply to get 18 but add to get 9 would be 6 and 3. And again, if I were to FOIL this out, I would get back at my original problem. Number 4. Again, I'm going to break it up into two binomials. A squared is a times a. So again, C is positive, so that means they're both going to be plus, plus, or minus, minus. But B tells me that they're going to be both pluses. So then I read it backwards. Multiplies to get 24, but adds to get 10. Two numbers that multiply to get 24, but add to get 10 would be 6 and 4. Number 5. Okay, we have two binomials, so k and k to get k squared. So C is positive again, which means they're both going to be plus or minus. And since my B is positive, they are both going to be pluses. Okay, hopefully we see somewhere they're both going to be negative, but we're not there yet. So then I look at, read it backwards. Multiplies to get 5, but adds to get positive 6. Multiplies to get 5, but adds to get positive 6 would be 5 and 1. Number 6, another one of these. So I have my two binomials, y times y. C is positive again, so they're both going to be positives or both going to be negatives. Since b is positive, they're both going to be pluses. Read it backwards. Multiplies to get 1, but adds to get 2. Two numbers that multiply to get 1, but add to get 2 would be 1 and 1. Okay, so those 6 are all similar because they are both positive. Okay, if I look at number 7, it changes here, but it's the same idea. So we're going to break it up into two binomials, n times n. This time though, C is negative. That means that both signs are going to be different. One's going to be positive, one's going to be negative. So I have to be extra careful here because it matters where I put my two numbers that I'm going to do the math on. Okay, so just keep that in mind. So I'm still going to read it backwards. What multiplies to get 18 but subtracts to get 3? Multiplies to get 18, but subtracts to get 3. So the two numbers that I'm coming up with are 6 and 3, because 6 times 3 is 18, but then when I subtract them, I get 3. So correct. But it matters where I put the 6 and the 3. Well, here's how it matters. I'm going to put the bigger number, so the 6, with the sign that b is. So since b is positive, I need to put my bigger number 6 with the positive. And then the 3 goes where the negative is. And now I can check to make sure I put them in the correct position by foiling. N times n is n squared. N times negative 3 is negative 3n. 6 times n is positive 6n. And 6 times negative 3 is negative 18. So when I combine these like terms, negative 3n plus 6n is positive 3n minus 18, and I did end up back at the beginning. If I had put 3 on the positive and 6 on the negative, then I would have ended up with negative 3n, and we didn't want 3 to be negative. So it really matters where we put those. So let's do another one because 1 is not enough. So here, I know my signs are going to be different because C is negative. So one's going to be positive, one's going to be negative. If I read it backwards, I want to find two numbers that are going to multiply to get 8, but subtract to get 2. Multiply to get 8, but subtract to get 2, and I come up with 4 and 2. Now, 4 times 2 is 8, and 4 minus 2 is 2, right? But let's see. Where do I put the 4? Where do I put the bigger number? Well, since b is positive, that means 4 needs to be positive and 2 can be negative. And again, I can make sure they're in the correct position by foiling this out and seeing if I end up back at the original problem. So let's keep practicing some more. Let's do a few more of those. So I wish it would change. It'll change here in a minute, but let's do a few more of those. So number 9, okay, two binomials, okay. So I know that there's going to be plus minus because C is negative. Now I need to read it backwards. Two numbers that multiply to get 10 but subtract to get 3. And the numbers I come up with are 5 times 2 because 5 minus 2 is 3. Now 5 is going to go with the positive because my B is positive. So I always put the bigger number. With what B is, the sign that B is. Okay, number 10. Okay, I'm going to break it up into two binomials. So again, we're going to have plus minus because C is negative. What numbers multiply to get 54 but subtract to get positive 3? Multiply to get 54 but subtract to get 3 would have to be 9 and 6. Okay, because 9 times 6 is 54 and 9 minus 6 is 3. Now, if I look, 9 is the bigger one, and so 9 has to go with positive because the B is positive, and 6 goes with the negative. Okay, number 11. Okay, since C is negative, it's going to be plus minus also. Okay, multiplies to get 45, but subtracts to get 4. and I come up with 9 times 5, because 9 times 5 is 45, and when I subtract 9 and 5, I get 4. Now, since 9 is bigger, I want to put it with the positive because b is positive. Okay, number 12, break it up into two binomials. C is negative again, so I'm going to do plus minus, and since 28 multiplies to get 28 but subtracts to get 3, multiplies to get 28 but subtracts to get 3, and sometimes it's just trial and error, there we go, is 7 times 4. Because 7 times 4 is 28, but 7 minus 4 is 3. Now 7 is bigger, and since B is positive, 7 is going to go with the positive. I know we've only seen some where the bigger number goes on the positive, but there will be times where B goes on the negative. If I look at this one, okay, its C is also negative, so I know it's going to be plus minus. Multiplies to get 30, but subtracts to get 7. Multiplies to get 30, but subtracts to get 7 would have to be 10 times 3. Since 10 is bigger, I want to put it with the positive since B is positive. Okay, one more of these, so we'll see some different ones here. Okay, since C is negative, I'm going to do plus minus, and I'm going to read it backwards. Multiplies to get 6, but subtracts to get 5. And comes to mind as 6 times 1 because 6 minus 1 is 5. Since 6 is bigger, we're going to put it with the positive because B is positive. Not because the bigger number always goes with positive, so be careful. Okay, let's change it up. So this is where we're going to see some different ones. So this one, C is negative, but so it's still going to be plus minus. If I read it backwards, multiplies to get 63, but subtracts to get 2 would have to be 9 and 7, okay? Because 9 times 7 is 63 and 9 minus 7 is 2. Now, 9 is bigger, but this time, since B is negative, that's what matters. 9 is going to go with the negative and 7 is going to go with the positive. So you see the difference, okay? Let's do another one like it. Okay, so plus minus because C is negative. Multiplies to get 3 but subtracts to get 2 would be 3 times 1. 3 is bigger, and since B is negative, 3 is going to go with the negative. 1 goes with the positive this time. Okay, two more of these. So 64, so it's negative, so it's going to be plus minus. Multiplies to get 64 but subtracts to get 12 would have to be 16 and 4. 16 times 4 is 64, but 16 minus 4 is 12. And since 16 is bigger, I'm going to put it with the negative because B is negative, and then 4 would go with the positive. Last one of these. So I have negative, so it's positive, negative. Read it backwards. Multiplies to get 72, but subtracts to get 14. That would have to be 18 and 4, because 18 times 4 is 72, and 18 minus 4 is 14. Since 18 is bigger, I'm going to put it with the B, which is a negative. So 18 has to go with the negative, okay? I want you to also keep in mind that I wrote it where I put positive, negative, but I could easily switch these where you could see it written as x minus 18 and x plus 4, just in different order. They're the same exact thing. I'm just used to putting plus minus, so don't worry there. So then we're going to look at what happens if I include a GCF. Okay, so what we have to also consider is that there could be problems where there is a GCF to begin with rather than just a basic trinomial. So, and then we'll see some where there's not a GCF, but there's still a number out in front here, a leading coefficient, but that's for a later day. So if I look at number 31, okay, 4, 12, and 8 have a GCF of 4, okay? So if I look at what's left, I have 4n squared divided by 4 is n squared. 12n divided by 4 is 3n. And 8 divided by 4 is positive 2. And now it becomes a basic trinomial. So I'm going to bring down my GCF, break this up into two binomials, and then I follow the same rules that we've been talking about this whole time. So n times n is n squared. since 2 is positive, the C is positive, that means they're both going to be the same sign. And that means the both signs are going to be positive because the B tells me that, okay? Then I read it backwards. Multiplies to get 2, but adds to get 1. And the numbers that come up are 2 times 1. And it doesn't matter where I put the 2 and the 1 because they're both positive. If I look at 32, the GCF would be 2, okay? So I have 2x squared divided by 2 is x squared, negative 8x divided by 2 is negative 4x, negative 24 divided by 2 is negative 12. And now it becomes a basic trinomial. Again, I'm going to bring down the GCF. And then I'm going to break this up into 2 binomials. X times x is x squared. Since C is negative this time, one's going to be positive, one's going to be negative. I'm still going to read it backwards. So what two numbers multiply to get 12, but subtract to get 4? And the numbers that come to mind are 6 times 2. Because 6 times 2 is 12, and 6 minus 2 is 4. Now, since 6 is the bigger number, I'm going to put it with the sign that is B. And since B is negative, that means 6 goes with the negative, and then 2 in the positive. Number 33, the GCF of 3y squared minus 15y plus 12 is 3. So 3y squared divided by 3 is y squared. Negative 15y divided by 3 is negative 5y. And positive 12 divided by 3 is positive 4. Now it's a basic trinomial, so I'm going to bring down my GCF and break this up into 2 binomials. Y squared is y times y. Since C is positive, that means they're going to be the same. Now here's the first one that we're seeing because there was none before. Since C is positive, they're both going to be the same. But this time, both of them are going to be negative because the B is negative. So this is the first time we're seeing this combination. And then I'm going to read it backwards. What multiplies to get 4 but adds to get 5, and that's 4 times 1. Because 4 times 1 is 4, but 4 plus 1 is 5. And this one doesn't matter where I put the 4 and the 1 because they're both negative. 34, the GCF is 3, so if I look at what's remaining, not just 3 actually, because they also have a GCF of an A. So 3a cubed divided by 3a is a squared. Wish I could pay attention. And then 30a squared divided by 3a is positive 10a. 63a divided by 3a is positive 21. Now it's a basic trinomial. I'm going to bring down my GCF and break this up into 2 binomials. Since C is positive, that means they're both going to be the same. And they're both going to be positive. Then I read it backwards. What multiplies to get 21 but adds to get 10? And the two numbers that come up are 7 times 3 because 7 plus 3 is 10. It doesn't matter where I put the 7 and the 3 because they're both positive. 35, the GCF is 2. I have b squared because 2b squared divided by 2 is b squared. 10b divided by 2 is positive 5b. And 12 divided by 2 is positive 6. I'm going to hold on to that GCF and break this up into 2 binomials. Since C is positive, that means they're both going to be the same. That means they're both going to be positive because the B tells me that. Read it backwards. What multiplies to get 6 but adds to get 5? The only thing that comes up is 3 times 2. It doesn't matter where I put the 3 or the 2 because they're both positive. Last one. My GCF is 5. So 5x squared divided by 5 is x squared. Negative 15x divided by 5 is negative 3x. And negative 140 divided by 5 is 28. Bring down my GCF, and then I'm going to break this up into 2 binomials. So since C is negative, that means one's positive, one's negative. Read it backwards. What multiplies to get 28 but subtracts to get 3? And the two numbers that come up are 7 times 4 because 7 minus 4 is 3. Since 7 is the bigger number, I need to put it where B is negative. So that means 7 needs to go where the negative is and 4 needs to go where the positive is.